Hi everyone, this is IREC-E. You're welcome to this tutorial. Now in this video we are going to learn structural design using Orion. This is in response to some students' request asking me to teach structural design in Orion. This video is going to cover the preparation stage right from the AutoCAD down to saving it in a DXF and then importing it into Orion, running the analysis and designing the structures. But just before we get started, I'd like to ask you to go ahead and like this video so that more people can see and benefit from it. And if you haven't already, please do well to subscribe to this channel so you get notification each time we upload new videos, because we make useful tutorials like this every week. Let's begin. Alright, now when you double click on the Orion icon on your desktop, this is where it brings you. Now the next thing you do is to go ahead and close here and then move to new project, and you can give the project a name or a code. So I say XYZ, then click OK. All depends on your local standards and country design code. For me, in this part of the world, we use the BS 8110. So I'm just going to click on it and then say import. Then here you're going to set up the paper size. This is the standard sheet, so but I'm just going to leave it at this, or maybe I can choose the A3 here. So here we also have the scale. All right, so whatever you're going to be doing is going to be working by this scale. So the next thing, I'm just going to say okay. So the next thing I want to do right now is to go to my CAD file. Now this is the structures I want to design. So one thing you have to bear in mind when designing the structure or when working inside AutoCAD is to make sure that you have 3 layers. For example, if I select this right now, you're going to see under these layers, you're going to see it as grid. Then I hit escape. If I click on this right now, you're going to see it as wall. Then for the columns, if I select this, you're going to see it as columns. So what I just have to do right now, since I'm satisfied with these 3 layers, I'm just going to select everything, click on W and say enter. So I'm just going to open up this box right here. So I'm just going to save it inside my desktop right here. But first of all, let me name it XYZ as well. I'm not going to save it as DWG file. Drop this down and then save it as DXF. So I click on this and then save it on the desktop. Okay, so I go back to Orion and I'm going to import it right into Orion. So I go here and see external reference drawing. Now another place you can find this external reference drawing is inside your file here. Click on file and then go to model/file import. Here you see external reference drawing. So I'm going to click on it, and here they are saying project should be saved before this process. Do you want to save the project? Say yes. We are going to load the file, but just before we do that, let me check this display reference drawing and check use DXF colors. So in case the project is loaded, it's going to use DXF colors, and the color intensity is maximum here. Click on load and move down. Here is the file. Select it and open the file. Check your units, say OK. Import members. So here you're going to see axis import option. You're going to check it. Then here column import settings. So import columns, I'm just going to check it. I just leave it as grid. That I'm going to read column labels just as is suggested. Then I click on OK. Now here is about building model check. It does not really matter. You can just say start. Number of errors is 0, so let's cancel this and then close this. Axes are numbered by Orion. The horizontal bears the alphabet, so you're just going to notice that. Remember, if I go back to all I did here is just to add axes, but right inside Orion Orion is going to label the numbers. Then the next thing we have to do here, if you check, the columns are numbered and the sizes as well, 225 by 225, also specified. Then the next thing we are going to do is to add beams. So you go here and pick beams and then specify the thickness of the beam. We'll go here and turn this to 225 millimeters, and then for B2 we are going to change it to 112.5. H board is the thickness on the bottom side, so we are going to take 450 millimeters. For the label, the numbering is going to start from 1 and then continue. So we are going to start from this point, click on the first column and drag it to the last. So we have a beam there. You can check the label, 225 by 450 millimeters. All right, so I click on the second one. So once that is done, the next thing is to add beam wall loads to our beams. So to do that, we are going to select one beam and right click. Once you right click here, you see edit beam wall load, because there's going to be a wall load on the beams. So once you select edit beam wall load, here you're going to see other options, but just leave it at wall. And then for wall opening, all of these parameters, we don't really need to specify anything on them. Come to this place, we have the dead load here. Now for me, on this part of the wall, my wall unit weight for that 225 millimeters thickness of wall is going to be 3.47. Then my wall height is going to be 2.7, and then wall thickness here is in meters, so it's going to be 0.225. Now with the specification here, you can see that there is now a dead load. So the next thing is to say OK. We're going to right click again and then copy beam wall load. The next thing you want to do is to start selecting all of these beams one after the other, but to make it fast, click on the first one here and then holding down your shift key, click on the last one, right click and paste copied beam load, then say yes. Now the next thing, I'm just going to put slab on top of it. So this is slab icon. You click on it to specify the thickness of the slab. For me, is going to be 150 millimeters. Then for the concrete cover, I'm going to use 25 mm. No, you're going to notice that the label is 1, so the numbering is going to start from 1 down the line. Then there are different numbers for different types of slab. So if I click on this place, you're going to notice the different types of slab. And as a matter of fact, for cantilever slab, is going to be this number 12. But we are not dealing with that now. We are just going to deal with the number 1 type of slab. Then the next thing you need to set up after this is to go and set up the load. Then for the self weight, you're going to have this 3.750. Then the dead load, and that is determined by the type of structure and the purpose of the structure you're putting up. Then here, I'm just going to use 2.2. For the imposed load here, you are going to place your cursor on this box and right click. I'm just going to select the number 1, which is general domestic use. Then here is ref level. Our reference level is 0.0. So here slab does not contribute to floor diaphragm. Alright, so you check it, and once you are done, bring it to the slabs and start inserting your slab. Close the slab. Then moving on, let's go and insert more stories. So we come here to this story, click on it and right click. Once you click on insert story 2, then the next thing is to click on OK. This is the second story. If you go to story 1 and double click, we have the story 1 and then we also have the story 2. Now on this story 2, what we are going to do is to generate the elements we need on this story 2. So we go back to the stories here, click on it and then right click. Here you see generate story. And then if you click on story 1 here, transfer it to story 2, we can come here and transfer the members we want. Here we have member type to be generated. We need the columns, we need the walls, we need the beams, but the slabs will not be generated on the next floor because the next floor is going to be at the roof. So we are going to uncheck the slabs. Once you're done, click on OK and close. So here we have the story 2. If you look closely, you're going to notice that the label is now 2C9, 2B3. Then if we go back to story 1, we're going to notice it's 1C9, 1C7 and the rest of them. So here we have it as story 2 without slabs. If you go to plan plus 3D, once you click on it, you're going to see the plan one side and you see the 3D one side. However, the top floor here doesn't require beam wall load. So if I select one of these, holding my shift key and select the last one, I'm just going to right click and delete beam wall load. Say yes. But the thickness is no longer going to be 450 millimeters because there is no slab on top. I'm going to go by 300 millimeters. So what I'm going to do is to turn this back to the plan. I click on the first one, hold down the shift key and click on the last one, right click, and then click on properties. So I'm just going to click on this one after the other and change it to 300 millimeters. Now once you're done, you can close. You go back to 3D, then you can select animation just to see what we've done there. Alright, this is just to rotate it in order to see, but at the end of the day you can just close it back and come back to the plan view. So on the plan view, let's be on story 1. At this point, click on run to select materials, go building analysis. So right here on the pre-analysis stage, what we are going to do is to click edit materials. So here unit weight of concrete in my own country here is 24. Then unit weight of block for 225 block is going to be 2.87. The coefficients of thermal expansion, we can leave it the way it is. So we are going to start with concrete grade. For columns, we are going to select 20/25, all right. Then you apply it to all members and add, say OK. And then for steel grade, we click on it and choose grade 410 type 2. So once you select that, we're also going to apply it to all members, add, say OK. Under column here, the bar sizes is going to be Y16, and then let's just uncheck every other member here. You can specify just one bar size, or you can give it option either this or Y20, so that during design the software will select the suitable design for a particular column. I'm just going to uncheck. So for the purposes of clarity, let me leave it at Y16. Say OK. Actually, I'm not designing any structural wall, so I'm just going to leave that. And then I come under beam. So I click on this. I'm also going to uncheck this and uncheck this and leave Y16 for beams. Uncheck this and uncheck this as well. Click OK. Then slab, I'm just going to open this and leave Y12. Click OK. Or rib slab, I can also leave Y12 for that. Say OK. For foundation, is a simple structure. So for foundation, I'm going to leave Y12. click on OK. Then for links, I'm going to leave Y8 for link. No need to select any bigger one, it's just a simple structure, but you need to know what diameter of material you need. So we're going to leave for links Y8 and say OK, and then hit OK once again. Parameters, click on parameters just to work on your foundation. Here we have allowable stress of soil. So before you do a structural design, you must have gotten your soil report, soil bearing capacity of the site. So let's assume for this structure is 100 kilonewton per meter square. So I'm just going to use 100. And then we have soil subgrade coefficient. Here we have this. Then if you click this, you expand it to see more options. So we have all of these. Then it can be clay soil and the rest of them. So let's just go for medium dense sand, and then we click on that. Then the next thing, you go lateral loading. Here you don't need to set up anything. Then for lateral drift, you can check braced on direction 1 and braced on direction 2. And then for title, here we have the project header. Give it a header like STR this. Alright, so let me say XYZ. Then for made by, you can put your name there. Let's say IREC E. Then checked by, you can put maybe your supervisor's name, DD West. Then here project number, what number is the project, then September 2014. Say OK, click on model option, then you check XY and torsion permitted, so that's okay. For rigid zone, you can reduce it to 25%. You go back to analysis. For loading combination, automatically Orion will update all the loading combination. Alright, you don't need to add anything, just say OK, close this up, and then save all your setup. Then the next thing, before you go back to run, you can go to setting and go to general settings. You can come to your company. Let's use IREC E. You don't really need this automatic save intervals. It means the intervals at which Orion will prompt you to save your work. So you can put 30 minutes, 20 minutes. As here you say automatic save options will be disabled when 0 is entered. Just say OK. Then go back to setting. Look for beam design setting, story beams. You come to parameters of the beam. We have minimum beam steel diameter is 16 mm. What about the maximum? That is where the option I explained to you initially comes in. If you are chosen 20 mm as well, that means under the maximum here you would have seen 20 mm, but because I just chose 16 mm, is still the same 16 mm. So under maximum you impute it. Then for links, now I have Y8 for maximum as well. If I had chosen Y10, you would have seen Y10 here for maximum. So both minimum and maximum is Y8. Then let's go to detailing. Under detailing here, you click on sections. Now right here under sections, the next place you need to click on is all beams. Then check span sections only. Your sectioning is going to be on each span. Click on steel bars and links. Now this is how your beam reinforcement is going to look like, and is looking ugly in my opinion. Even the sectioning, this is how it's going to appear. So here, the next thing I suggest you do is to uncheck this. You have a different kind of call out on your sectioning. If you uncheck this as well, you would notice that there's a change on the reinforcement on the beams. When you uncheck this, display kinks in detail, so you notice all of those things are removed. Then you can explore more of this to see how they display on the beam. So I think I'm fine with the way it is right now. Then the next thing you're going to do is to save it. Then you go back to setting. You can also go to column design setting. So here we have steel bars. Once you click on it, the next thing you need to set up here is the longitudinal bars. So once you click on the longitudinal bars, you also have column bar size. Then for maximum, click on that because I didn't specify 20 mm, so you're good to go. All of these ones are in order. You don't really need to set up anything. Just say OK. Then you can set up your slab as well. Slab design setting. Then for slab, click on steel bars. We have the minimum steel bar size as Y12. Then for bar spacing, we have minimum is 100 mm, the maximum is 250. But I can reduce this maximum to 150 mm so that my bar spacing cannot exceed 150 mm. And then the next thing, you look at the curtailment. So you check whichever one that makes meaning to you, and then view and check whichever one that makes sense to you and say OK. Then the next thing I want is the foundation setting. Let's go to foundation setting. Now here you check design this. Minimum steel bar is 12 mm, distribution bar size 12 mm. Now maximum steel bar spacing, let's also choose 150 mm. So here I'm going to click on OK. Then the next thing before we run analysis is to go to our stories here, and then I click and right click on it, edit story. First story bottom level is 0, but foundation depth, I'm just going to say 900. Then assume roof as normal story, click on that. Now at this point, run the analysis of these structures after you must have saved all your setup by clicking on this point or using the Ctrl S key. So I go to run building analysis, and then here is analysis. So under this dialog box here, you're going to observe building analysis and design. You're going to see this red sign here, meaning none of those members has been analyzed. So once we run the analysis, it's going to mark here with green. You're going to see that. Now the first thing we are going to analyze is the beam reinforcement design. We can leave the column for now and analyze it after. We check this and check this. They say reselect T-bars, then start. Of course, you say reselect members, alright? Then building analysis completed. Once you say OK, analysis, click on post analysis, then click on beam reinforcement design. With all these green markings, it means they all pass the analysis. So the next thing you want to do is to export it to AutoCAD, and to do that, go to detailed drawing, then you click on automatic detailed drawing. You're going to have it for story 1 and for story 2. So I click on story 1 and 2 as well. And then here they say display every sheet prepared. Check it and then say OK. It's going to open in AutoCAD. So here is the first one and here is the second one. If you check, this is the second one. That is the roof beams. You can see the call out 2Y16 and T1. That is the top number 1. 2Y16, the first number, and bottom number 1. So just like that. And then we have the table, the steel bar quantity table, and then for the other one you're going to see the same thing, alright, and the numbering of the beams are there, the thicknesses, the sections of the beams. So we go back to Orion and then cancel this. Then go back to design. You can also export the design report, which is the calculation sheet, by clicking on this, and the font, you can change the font type depending on your choice. Then you say OK. Now here is it. You can open it in a PDF file. So once you click on PDF, you have opened that on the PDF file. So close here and go back to current tab, exit and return back to Orion. So what that means is that the calculation sheet, that is the report, is going to be on a different folder. For example, if I choose to close this, which I'm going to show you how to locate it later, it's going to be on the XYZ folder. So I'm just going to save this, then I close the next one, save, then I return to Orion, and then I'm done with the beam right now. Then I close here. You go to run again. Instead of going to building analysis, just go to column section design, then click on column section design. Of course, there's a warning here: column stroke wall limit and minimum steel bar diameter not defined. So since you've had a warning like this, what you need to do is to close this, then close this, and go to setting, go to column design setting, then go to steel bar, longitudinal bars. Of course, I have the minimum and the maximum set. Then for wall bar size, they are all set as well. Then bar spacing maximum method. Of course, we have different methods of bar spacing, so I'm using maximum method. Then this minimum is set, then the maximum is set. Click on OK and go back to run column section design. In order to take the latest revision into account, do you want to save changes? Yes, because that's the only way it will be updated. Then here say OK, then go to column design batch mode, reselect members, design, process completed, close this. So you're going to see that all the columns have passed analysis. Then just like the beams, we go to detail drawing, click on automatic detail, select story 1, select story 2, display every sheet, then OK. And so we can also close this, say yes, we save it here, close the next one, yes, and save, return back to Orion, then close this. Then here we have the column schedule. So if I click on this column schedule, click on the first one, hold down the shift, click on the last one, then draw. Of course, it's going to be on a dimension sheet, then say OK. We have the schedule this way. Of course, since what we have on the ground on the first floor is the same as the top floor, we're going to have it as below. Then you can also save this and present it if you want. Then save. Then I go back to this, cancel this out, then return back to design. Design report, you can also move it. Say OK, turn it to PDF, then close. Of course, it's going to be saved inside the same folder. Then here we are going to close this also. Then the next thing is to place the slab strips, after which we are going to design the slab. Here is the strip, then we click on it. Here we have analytical strip, then this is for slab, this is for bob, then this is for cantilever, and then all our strip is going to run from end to end, which is bob. So in that case, I click on bob for a start, click on bob again for the end. So holding the control key, then I click the last one, click here, hold control key, click here, holding control key, then I go to the vertical, the same thing, then I close this. We can as well cut a section here. So how do we do that? You click on this, which is the section icon, click on it, click on that, then click the first point, holding the control key. The second point here, you pull it up and drop it somewhere there. Now looking at this section, there is no reinforcement inside. You come over to this place and show steel bars. Once you click on show steel bars and update it, Then the next thing is to run analysis on the slab by going to run and come to slab analysis and design. You click, then all stories. Of course, it's just one story, but you may decide to check all stories. Here for the reinforcement section option, we have check design. Then in bracket, it says do not modify existing steel. So everything is in order, then you can go ahead and design. You can cross-check your reports if any of those slabs is failing. We have this sufficient. Of course, L over D equals to 27.1, which is less than 52. Then you can cross-check all of them. Anyone that is greater than 52 is going to fail. Then once you're done, you can also convert it to PDF and then close it. It's going to save into the same folder as others. Then exit, cancel, and then you may actually need this during your arrangement. You can just decide to export this into an AutoCAD file immediately by going here to this DXF and then clicking on it, so you can browse into your file where you want it to be saved and save it here. It opened as an AutoCAD. Then while you are now closing this, save it as a DWG file instead of DXF file. So here is already in DWG. Then you can save, then you return back to this. At this point, the next thing we are going to analyze is the footing. So to do that, we go to story 0 and double click, and we can also set it on plan plus 3D. Click on any point and zoom it out. Select one column, then right click, insert part base. Then right here, you're going to see the label of that part base, but the footing depth here is 400 millimeters. This is just 2 stories, so the 400 is going to be too much for it. You are the one designing, so you should be the one to assign the thickness. I'm just going to turn it to 250 millimeters, and then we have the taper height 0 mm. I don't need to set up any taper. Surcharge height, I can leave it there. Soil unit weight 18 kilonewton per meter cube. Then allowable stress of soil, I've already set this up as 100 kilonewton per meter square. Then concrete cover for the foundation here is 40. Steel bar for x-axis is y12, y-axis is y12. Calculate is going to show that Lx is 1000 millimeters and Ly is the same. Then square footing, you check that because it's going to be a square footing. Just click on OK and OK. So we have that there, 1000 millimeters by 1000 millimeters size. Now the same process can be repeated on all others, but because it's time consuming, we are just going to delete by clicking on the delete button, and this time around I select everything. Having selected everything, I right click on one of them. Here in this case, I'm just going to say insert part base. To insert part base, in this case, create square footing. I'm just going to check create square footing. So I'm just going to check this and say OK. All of them are created. Then I turn this back to plan. Now to generate calculation sheet for all of this footing, what I have to do right now is to select everything. I right click. So here we didn't design for pile, it's just pad, but I'm just going to select this. In this case now, because we didn't design for pile, instead we designed for pad, we are going to select this option here. Then on the report title, I click on this point, then I can edit this file that is written here. At the end of the day, you click refresh. So I go back to general, move it to PDF file, then I close it. Then I use escape key to exit out of this. Then you can also export this to AutoCAD by clicking on DXF here. say OK, then I can close this up and say yes. It's going to save as well, just like others. One thing you will notice is that all of these part bays are not of the same size. Of course, they took their sizes based on the functionality and the position of that column. When you get to this point, what you will do is to come to this place. You see foundation detail. We're going to pull out the foundation details by clicking on this place. First of all, before pulling them out, you're going to set up a new sheet for that. Of course, this is A3, and then you can say OK. Then for the 1000 by 1000 millimeter, you pull it out. Then you will notice that anyone that is highlighted can always remain on the clipboard. Wherever you place it is going to go with you. Then the next thing you want to do is also to export this to AutoCAD by clicking on this and then say OK. And once you are done, you can close this and say yes. With this, we have come to the conclusion of this tutorial, and if you've learned anything new, please don't forget to subscribe to this channel for more, and make sure you leave a comment below the comment section, and also suggest what kind of video you want to learn so that we can produce it for you. Thanks for watching, and see you in the next video.